This section on DMET Console software is about allele translation with a focus on the phenotype report and customizing the reported phenotypes. The allele translation operation generates 4 reports summarizing data. This section was only going to describe the phenotype report containing the predicted enzyme phenotypes plus the haplotypes that were used to predict the phenotypes. Before I go into the report, it's helpful to understand how we generate the resulting phenotypes from star alleles. This is done by first collating information from the literature on the reported enzyme activity resulting from these different forms of the gene, in this case CYP1A2. These are all the alleles that are reportable with DMET+, and we collated the gene enzyme activities: normal, reduced activity, unknown activity if the information wasn't clear enough, in some cases no activity at all. When we looked at these PubMed IDs, or these references, we also noted if it was an in vivo study or just an in vitro study. In vivo has a higher level of evidence. After we assembled one of these tables for each of the genes that we do phenotyping on, we then decided on a generic lookup table of activities that would and what the resulting metabolizer state is. For example, if we have a normal activity allele paired with another normal activity allele, we would report EM for extensive metabolizer. That's normal metabolism state. And you can see the other combinations as well. If we pair a normal with a no activity allele, this metabolizer file would report an intermediate metabolizer, and so on. This is a generic lookup table used by many of the genes, but some of the genes do have different lookup tables. I should point out at this time that users will disagree as to what this lookup table should actually be. For example, another user might choose to pair a normal activity and a no activity allele and still call it an extensive metabolizer. The last step in creating this reference file was to merge the activity information and the metabolizer lookup information into one master metabolizer table where each row corresponds to a pair of star alleles for a given gene. When the software determines a pair of star alleles for a particular sample, it looks up the relevant row in this table and reports the resulting phenotype and associated pair of activities. So this table has every combination of star alleles that can be reported for each gene. This is just one gene that's being shown. In addition to the information that's reported in the phenotype report, there's also evidence fields and PubMed fields. So for example, for allele 1, star 2A, activity 1 is increased for 2A. Its evidence level is in vivo from the publications cited in the PubMed IDs. Now let's look at a phenotype report. I'm starting by looking at only one row of the report. So for a particular sample and a particular gene, what is its predicted phenotype? In this case, it's EM or IM. That's a single code. Where did this come from? Well, it started with knowing the star allele calls for the sample. In this case, it's actually 2 possible combinations. We have multiple possible diplotypes. It could be either star 1A, star 1L, or star 1C, star 1F. It turns out that both combinations of these are a combination of a normal activity allele and a reduced activity allele. And the generic lookup that says when you're pairing a normal and reduced activity allele, we report the code EM or IM, extensive or intermediate metabolizer. If I look at the other genes for this sample, and the phenotype report only reports one row for every gene sample, you can see what it looks like for the other genes. We have, in some cases, we use different nomenclature. For example, for the N-acetylated transferases, we have rapid gene activities, or rapid slow, as in rapid or slow acetylators, and that's why the phenotype call uses the terminology used for those genes. RA is rapid acetylator, I is intermediate acetylator. If I just take the phenotype report and want to do a quick summary on the contents, I can put it into Excel and create a pivot table. So here's an example where I've selected 4 fields from the entire file of the pivot table, and I'm now filtering to only show the results from one gene at a time, in this case CYP1A2. Summarize on the rows first by gene activity, grouping first by gene activity, and then by known call. So that's what you can see here. Normal is gene activity, and then the known calls for that pair of gene activities. I'm going to create columns, one column for each phenotype call, and then count how many times that row appears. So this was a data set of 597 HapMap samples, so the numbers add up to 597. 139 of those samples called star 1A, star 1F, 99 called star 1A, star 1A, 69 called star 1F, star 1F. All 3 of those are considered a pair of normal activity alleles, and as a result, they were all put into the extensive metabolizer phenotype. Similarly, we have a number of samples that fall into the normal or reduced activity alleles, and we have 44 samples that fell into the reduced activities with star 1L, star 1L, and they were reported as intermediate metabolizer. 2 of these samples did not report a known call, and that is because they had a pair of haplotypes where at least one of them was not defined in the set of alleles in the translation table. And because they had no known call, they weren't able to be assigned to a phenotype, and so they were put into the generic unknown phenotype call. 2 samples out of 597 not giving a clean call is actually pretty good. I mentioned that some users may disagree on what phenotype assignment is made given a pair of star allele calls, and there's a number of reasons for that. One is there are known activity differences based on the substrate that the particular enzyme is metabolizing. So a particular enzyme is not always going to be reduced activity. It depends on what enzyme it's metabolizing. However, this metabolizer file is more of a generic file. It's certainly not tuned to specific drugs. So that's why we want users to be able to tune it for their own purposes. The other reason is that even if they agreed on what the pair of activities are, they might not agree with the name that we report for the phenotype. For example, some users may prefer not to have an ambiguous code like EM or IM. They might prefer to give it a cleaner call. So for that reason, we actually want you to make your own library file once you're comfortable doing so. So instructions for doing this are reported in the DMET Console help that comes with the software. You can also download it as a PDF separately. There are some sections on how phenotyping works and how to modify the metabolizer library file safely. Examples of things you can edit. Well, what if you don't want some of the genes reported in the phenotyping report? There's actually 2 ways of doing that. One way is that when you do your allele translation, you can supply a marker list that says only do translations on these markers, so that if you're not interested in other markers or other genes, you just don't include them in the list. Or if you'd like, you could also modify a copy of the metabolizer file and delete rows relating to any genes that you don't want reported. And if there are no entries for a particular gene in the metabolizer file, then the phenotype report won't have those genes. If you want to generate phenotypes on genes that aren't in the metabolizer file you have, you can always add additional rows. The format's fairly straightforward. Or you can modify the reported phenotype by just editing an entry in the file. Once you've edited your copy of the metabolizer file, you need to put it in the same folder that DMET Console uses when it looks for its library files. Then switch over to DMET Console, edit the Configuration Options button, which will open this options window. Select the Translations tab, which specifies which library files are being used. And then you can switch over to your custom one by browsing and selecting from available metabolizer library files that have been found in your library folder. And at that point, you can use it. Let me look at the header of a phenotype report, and I've put some text in red just for emphasis. First of all, the results are entirely a function of what metabolizer library file you use. So if you modify it, please modify a copy, and so that the name of the file is meaningful for you. It's important to understand these other sections. The phenotype call and gene activity interpretations for a known call are supported by differing levels of evidence from in vivo or in vitro research studies. Please refer to the metabolizer file, that's the file that's listed up here, for a list of references. The actual phenotype and gene activities may be dependent on the substrate and dose, so you are responsible for reviewing the metabolizer file for accuracy. We have some other sections here that describe some of the call codes. Actually, anything that starts with this £% prefix is information that was pulled from the header of the metabolizer file. So if you want to change what information is put into the header in your custom phenotype reports, all you have to do is modify these lines in the metabolizer library file.